In this video, I am going to explain direct variation with a slope. Direct variation is in the form of y equals kx, where k does not equal 0. Looking at this formula, you might recognize y equals mx plus b. And that was the slope-intercept formula that I went over in the pre-algebra lessons. In this case with direct variation, there is no y-intercept, so you can take away that b, and m and k are variables, so m can be equal to k. K is just a different variable that we use to describe direct variation. In our case, k is the constant of variation. An equation that fits this formula would be y equals 2x, where 2 equals our constant of variation. Graphing that, there's no y-intercept, so it's always going to cross the point 0, 0. Our slope is 2, so we're rise over run, 2 over 1. Once we get a couple points, we can go ahead and draw our line, connecting the points. Now, remembering our slope through the slope formula, we can see that one of our points is always going to be 0, 0. So if we were to use that as our second point, y2, x2, we could use this second point, 1, 2. So 1, 2, and 0, 0 will be our x1, y1, x2, y2. Plugging those in, we're going to get that m is equal to 2 minus 0 over 1 minus 0, which is simply 2 over 1, which is our slope, 2. Let's say that y equaled 3x. 3 is our constant of variation k, and we're still crossing over this point 0, 0, except this time we're just going rise over run up 3 over 1. So that's going to be a steeper slope. But again, if we use the point 0, 0, and this time instead of 1, 2, we use the point 1, 3, we're going to get that our slope is just m equals 3 over 1 because we're subtracting 2 zeros from the 3 and the 1. So that's just going to be equal to 3. And that's how we get our constant of variation.